हॅलो हॅलो.
येस सर.
आवाज येतो ना मॅडम?
येस.
ओके 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 थँक्यू.
सर आवाज थोडा कमी येतोय तुमचा पण.
नवले मॅडम.
येस सर.
सर जॉईन झालेत का? आय विल कॉल.
सर नाही जॉईन झाले सर. हां.
हॅलो वैष्णवी, एम आय ऑडिबल?
येस
येस
येस.
येस.
मी जॉईन झालोय मॅडम.
हां येस सर.
देशमुख सर.
दोंडे सर, देशमुख सरांना बोलले का तुम्ही?
हो बोललो सर, त्यांना सगळं बोललोय. अजेंडा पाठवला. हो लिंक पण पाठवली. फोन करतो सर मी त्यांना. हा देशमुख सर 2 मिनिटात जॉईन होते सर. होत आहेत ते.
हा दोंडे सर नमस्कार.
हा नमस्कार सर. नमस्कार.
नमस्कार. बोरमाने सर जॉईन झाले वाटतं. सर
हो
नमस्कार.
हो.
या.
देशमुख सर नमस्कार.
नमस्कार नमस्कार सर.
थँक्यू थँक्यू. अतिशय कमी वेळात शॉर्ट नोटीस मध्ये
आपल्याला काय घरचं
म्हटलं आम्ही हक्कानं.
हो काही प्रश्न नाही. थोडं ऍडव्हान्स मध्ये माहित असलं म्हणजे हे करता येईल. ऍक्टिव्हिटीज असं कंटिन्यू.
येस सर. सुरू करायचं का सर?
येस येस
येस. नवले मॅडम.
येस सर.
येस प्लीज स्टार्ट मॅडम.
Okay, sir. Good afternoon and warm welcome to one and all. I, Mrs. Vaishnavi Navle, Assistant Professor in ENTC Department, welcome our today's Chief Guest, Dr. R.R. Deshmukh Sir, Professor, Dr. BAMU in Aurangabad, Dr. D.S. Bormane Sir, Principal, AISSMS College of Engineering, Dr. S.B. Dhonde Sir, HOD, ENTC Department, AISSMS College of Engineering, Mr. S.B. Dhekre Sir and Mr. V.B. Gawai Sir, Coordinator of Event and all faculty members for online FDP on recent trends in machine learning. Let's begin our program by holy tradition to worship Goddess of Knowledge, Music and Arts. For Saraswati Vandana, I call upon Ms. Vidya Deshmukh ma'am.
या कुन्देन्दुतुषारहार धवला, या शुभ्रवस्त्रावृता, या वीणावरदण्डमण्डितकरा, या श्वेतपद्मासना, या ब्रह्मार्च्युतशङ्करप्रभृतिभिः देवै सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा.
Thank you, Vidya ma'am. Now I request the chief guest of event to please accept virtual felicitation. Thank you, sir.
Thank you. Thank you.
I request Dr. S.B. Dhunde sir to brief objective of workshop.
Thank you, madam. Good afternoon to one and all present for the inaugural session of Faculty Development Program on recent trends in machine learning under the aegis of ISF and PAC IET. I, Dr. S.B. Dhunde, Head of the ENTC Department and co-convener of FDP on recent trends in machine learning, welcome you all on this occasion. On behalf of All India Sri Shivaji Memorial Societies, College of Engineering, Pune, today's guest, respected Dr. R.R. Deshmukh sir, West Zonal Mentor, Governing Council Member of IIT New Delhi, respected Principal Dr. D.S. Bormane sir, and coordinator of today's FDPs, Mr. S.B. Dekre sir, and Vipin Gawai sir, and all organizing committee member and dear participants. Today you know that machine learning is a hot area. The objective of this workshop is giving a faculty, research scholar and student an in-depth understanding terminologies of the core concept behind machine learning and its applications. Also hands-on training using state-of-the-art tools. Workshop will equip the participants with the skill necessary to apply this two-line technique to solve the complex scientific business, which will increase the knowledge of faculties through interaction with eminent personalities from the industries and academics. The knowledge sharing will improve the teaching learning process to the students and benefit of the society. So I wish you best of luck to understand the new concept of machine learning. Thank you.
Thank you, sir. Now I request Dr. D.S. Bormane sir, Principal, ASMS College of Engineering, to guide participants.
Thank you, Noble Madam. Good afternoon, all. Respected Dr. R.R. Deshmukh sir, West Zone Mentor, my colleague in Governing Council, IIT New Delhi, HOD Dr. S.B. Dhunde sir, coordinator of this faculty development program on recent trends in machine learning under aegis of ISF and Professional Activity Center of IIT, Mr. S.B. Dekre and Mr. Vipin Gawai, all the faculty members, research persons and participants. I congratulate and appreciate ENTC department for choosing a very relevant topic which is a need of hour, because nowadays the 4.0 and we are going for now 5.0. This recent trends in machine learning really playing a vital role. There are various trends as far as the machine learning is concerned. I'm not going to detail about that, but just I want to mention some of them. And the good resource persons you identified. I'm definitely happy all the participants, faculty and students, those are attending this, take benefit of this because nowadays this topic is really required for everyone. It's not a cup of tea of computer or IT. It is now interdisciplinary aspects, and we are observing so many applications based on AI and machine learning, and we are getting benefit of that. Some of the trends in this machine learning is explainable AI. As this machine learning is becoming more prevalent in critical decision-making processes, there is a growing need for models that can provide explanations for their decisions. how the decision is taken, the explanation, and that is possible through this explainable AI, and which is aimed to develop transparent and interpretable machine learning models that can explain how and why they arrived at a particular decision. So this is one of the latest trend or area which is really helping for various applications. Similarly, federated learning. This is another trend in the machine learning where this technique enables multiple parties to collaborate on building a shared model without sharing their raw data. And this technique is particularly useful in situations where data is sensitive or confidential, such as in healthcare or financial industries. Similarly, reinforcement learning is another type of machine learning that enables the agents to learn by interacting with their environment and receiving rewards for positive action. And this approach has been particularly successful in developing intelligence systems that can play very complex games such as chess and other games. Edge computing is another area where it's a distributing computing paradigm that is brings the computation and data storage closer to the location where it is needed. Similar auto ML transfer learning, and there are so many new trends are there under this machine learning. Definitely in coming this particular program, the resource person are going to throw light on this, and definitely student will take benefit of this new technology. So once again, I appreciate department for choosing this latest topic and that to be trends in the machine learning and identifying the resource person. And special thanks to Dr. R. Deshmukh sir. In a very short time notice, he's accepted our invitation and he is available to guide us. Thank you.
Thank you, sir, for your valuable guidance. It's my privilege to introduce our today's chief guest, Dr. R. Deshmukh sir. Dr. R. Deshmukh sir, Professor in Computer Science Engineering, Dr. BAM University, Aurangabad, West Zonal Mentor, IETE, New Delhi, Governing Council Member, IETE. He is a visiting professor, Southern Federal University, Rostov, Russia, and member, Curriculum Advisory Board, Namibia University, Namibia. Committee member at AICTE as All India Board of Information Technology Education and member of Grievance Committee, All India Council for Technical Education. He is a principal program coordinator for the DST FIST program in department sanctioned by Department of Science and Technology, New Delhi, Government of India. He is editor-in-chief, CSI Journal of Computing, member, National Nomination Committee. He is a chairman, Board of Studies in Computer Science and Engineering and member of Academic Council, Dr. BAM University, Aurangabad. He has published 3 Indian patents, edited 12 books, and published more than 200 research papers in reputed international, national, peer-reviewed journals, conferences. He is reviewer and editor of several journals at national and international level. He has organized several national, international conferences, workshops, and symposiums. He has completed 5 research projects from UGC, and DST received grants of more than 1.50 crores. He has received Best Teacher Award for Outstanding Excellence and Remarkable Achievements in the field of teaching, research, and publication from IRDP Group of Journal, Chennai. He received the Bharat Ratna Mother Teresa Gold Medal Award 2015 for outstanding service in education and research to strengthen India's unity and economic development. His profile has been published in the 32nd edition of Marquis Who in World 2014, which consists profiles of more than 55,000 people working in different areas around the world. We are glad to have you as a chief guest, sir. Thank you so much. And I request, sir, to please address the faculty members.
Yeah. So, am I audible?
Yes, sir.
Yes, sir. Yes.
Okay, okay. So, thanks, madam, for a brief introduction. the convener of this 1 week FDP program, Dr. D.S. Bormane sir, who is principal of AISSMS College of Engineering, and we are, as we are working as a colleague in IIT New Delhi, and we are old friends. Along with the head of the department and co-convener of this FDP program, Dr. S.B. Dhonde sir, as well as Dakle sir and Gawai madam, and all the participants. So first of all, I would like to thank the organizer to invite me to have an opportunity to interact with the participants in this FDP program on recent trends in machine learning under the aegis of IET Student Forum and Professional Activity Center of IET New Delhi, as IET supports so many activities which are being catered or conducted at the level of engineering colleges as well as polytechnics for the engineers. So we can consider that this is also one sort of support or opportunity provided by IET to the that is engineering fraternity. So friends, as we know that AI is nothing but artificial intelligence, and which can be referred as a backbone of this overall ICT services. And we know that there are so many potential applications in the area of artificial intelligence and machine learning. So there are so many applications. The application area are spread all over the huge area. We can consider here, for example, healthcare area, in education, finance sector, transportation, customer service, or entertainment, manufacturing, service industries, as well as agriculture, environmental monitoring, and cyber security, and so on. So particularly in agriculture sector, this machine learning and AI can be used to monitor crop health, that is optimize irrigation and fertilization, and predict weather patterns in the we can say in the form of smart farming or precision farming, isn't it? Also, there are so many applications of this AI and machine learning in cyber security, as it can help to detect and prevent cyber attacks, as well as identify the persons of suspicious behavior, which is the most essential, because nowadays everybody is taking advantage or making use of this overall online services, starting from the booking of bus ticket to flight ticket, train ticket, or any sort of service. The common man, or even if to open the account, the person has to approach to the there is a help center, or in the Setu office or Setu center, to fill the online form. So I think everybody is making use or taking advantage of this ICT services, and the security is a major issue, and it is a big challenge to have a secure service to be provided to the common man, as well as in healthcare also. This can help in the diagnosis of the disease, analyze medical images, and even suggest personalized, that is, treatments for the patients, along with their application in transportation area, that it can be used to optimize routes for delivery of the transportation, and which will affect to reduce the traffic congestion as well as the cost. In customer care service also, this AI and machine learning chatbots can help, can provide the online support to customers 24/7, Again, in manufacturing sector, it can be used to optimize production lines, predict maintenance needs, and improve the quality of improve the quality control or the sort of things. Again, in the that in education sector also there are so many applications which can be used to that is create personalized learning plans for the students, provide intelligent tutoring, and help educators to evaluate the students' progress. Or in finance sector, we can say that it can provide or it can be used to detect fraud detection or frauds, performs risk assessment sort of task, and automate the financial task also. And also, there are so many applications in the environmental sector also, that is the monitoring environment. And by monitoring these environmental features, the prediction of some sort of that is calamities or weather prediction can be done, or environmental changes can be analyzed and predicted, or that is the pollution and deformation sort of applications can be addressed. And these are not limited to this. These are the some of the major applications, but there are applications in the research and development as well as defense, and there are so many application areas. So there is no limit, and that as a researcher, we have to try to provide that is ease of use, that is easy use of these applications or this AI applications have to be invented and have to be provided to the society as our the social responsibility. So I think uh, after completing this FDP, definitely the candidates will enjoy the feast of knowledge within these 7 days, and they can utilize the skills or that is knowledge obtained from this FDP, and that will be useful for their future career also. So here I will there is a announce that this FDP has been inaugurated, and all the best to all the participants, and thanks to organizers. Thank you, sir.
Thank you, sir, for your valuable guidance in the importance of machine learning. Thank you so much, sir. Now I request Mr. S.P. Thekre, sir, to present a vote of thanks for the event.
Thank you, ma'am. I'm audible.
Yes, yes.
Yes, sir.
Good afternoon, one and all. I, Santosh Dhekle, would like to propose oath of thanks on occasion of this inaugural ceremony of 1 week online FDP on recent trends in machine learning under the aegis of IET Student Forum and Professional Activity Center of IET. I am very thankful to Dr. R.R. Deshmukh sir for accepting our invitation as a chief guest for today's inauguration ceremony. I would like to extend my gratitude to All India Sri Shivaji Memorial Society's Honorable Secretary Sri Chhatrapati Maloji Raje, Joint Secretary Sri Suresh Shinde sir, and Treasurer Sri Ajay Patil sir for giving us opportunity to plan such type of activity. I also extend my thanks to our dynamic principal, Dr. D.S. Bormane sir, for giving us support and motivation for organization of this FDP. I am very thankful to our HOD, Dr. S.B. Dhonde sir, for initiation of to organize this FDP. I would like to thank organizing committee members, faculties. I congratulate and thanks to all participants for joining such wonderful FDP, which helps individual in daily teaching learning and in research work. I extend my thanks to media department of AISSMS Society. I extend my thanks to all speakers for giving their valuable time to conduct this FDP. Thank you very much. Thank you, ma'am. Over to you.
Thank you, sir.
Thank you, Deshmukh sir.
Thank you, sir. Thank you.
Sir, we can take one photo.
Yes.
Yeah.
Snapshot घ्या.
Yes. देखील सर कोण घेताय?
आता त्या भरतशीच बोलत होतो मी.
हा.
एकदम मेल पाठवून दे ना तर 2 दिवसात मीटिंग अरेंज कर म्हणतात.
हा मग काय म्हणतो मीटिंग लावतो म्हणे. मीटिंग लावतो म्हणे का काय मग?
लावतो म्हणला नाही झालं तर करू म्हणा.
बर.
All participants are requested to switch on your camera, please. वैष्णवी मॅडम तुम्ही घेताय का स्क्रीनशॉट?
Done, sir.
Okay.
Thank you, sir.
Thank you, Deshmukh sir.
Okay, thank you, Sunday sir. Thank you. Yes. Purmani sir. Okay.
Yes, sir.
Thank you.
Hello.
Just we can start now the session. Already madam is there.
Yes.
Shinde ma'am.
Yes. Dr. Swati ma'am.
Yes. I am there only. Yes, I am here.
Yes. Okay. Good afternoon, everyone. I welcome our speaker for today's session, Dr. Swati Shinde ma'am, and I request ma'am to please accept our virtual felicitation. It's my honor. Thank you, ma'am. It's my honor to introduce our speaker for the session. Professor Dr. Swati V. Shinde has completed her PhD in Computer Science and Engineering from Swami Ramananda Tirth Marathwada University, Nanded. She has a total 22 years of teaching experience and currently she is working as a Dean, R&D and Professor Computer Engineering, Pimpri Chinchwad College of Engineering, Pune. She has worked as a HOD IT for 7 years in PCCOE. Her research interests includes machine learning, deep learning, soft computing, artificial neural network, and fuzzy logic. She has published 100+ research papers in reputed conferences and journals. She received the 6 Best Paper Awards in different IEEE conferences. She has filed 7 research patents. She has received the DST research project grants of almost ₹37 lakhs. She also has received the research grant of SPPU University, Pune, the international FDP grant by SPPU, and also the conference grant by AICT. She is the certified trainer and ambassador of NVIDIA's Deep Learning Institute. She conferred the Dr. APJ Abdul Kalam Women Achievers Award by IIT Bangalore. She was awarded the Indo-Global Engineering Excellence Award by Indo-Global Chamber of Commerce, Industries and Agriculture. She also received the first award for her prototype by SERB at IIT Kanpur. She has delivered 35+ research talks in various workshops, STTPs, etc. She was the General Chair of IEEE Conference ICCU BEA 2018. Currently, she is a SPPU approved PhD supervisor and guiding 4 PhD research scholars. We welcome you, ma'am, for the session and I request you to please take over the session.
Yes, ma'am. Thank you very much for the warm welcome. Now, I would like to start the session. As you have shared that the session topic will be machine learning and predictive analytics by using machine learning. So I'm really very much thankful to the organizers that they have invited and they have given me this opportunity to share my whatever the knowledge I'm having. So let us start with the session. Can I?
Yes, ma'am.
I will. Just I'm sharing my screen. I hope screen is visible, right?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So thank you. So as already introduced, and this FDP is on machine learning. So different algorithms are covered as I have seen the curriculum of this particular FDP. So I thought I also should discuss on some of the algorithms. So first thing is, many times we are hearing nowadays AI, machine learning, deep learning, all these terms. So these terms are very much related to each other, but there is a thin line difference. So what is the relation among these terms that we will try to understand? Many of you, this might be a basic idea, but I thought that we should start with this particular thought that differentiation between this. So AI, machine learning, and deep learning. So artificial intelligence is a very broad domain. It is not restricted to the computer engineering only, because automotive also it will cover, or the robotics, and this data science, machine learning, or data analytics. So all these terms, wherever we are trying, our machine should be intelligent. That may be our washing machine, or that may be some manufacturing machine, or that may be a robot. So wherever we want that particular equipment or particular instrument or particular machine should have some intelligence. Not the complete intelligence of human being can be imitated, but some sort of intelligence they should have. And if that study of that particular thing is nothing but artificial intelligence, so it is a very broad domain, but it comes under the engineering discipline and not belong to the only computer engineering discipline. Okay. Now, machine learning, as we know, it is a subset of the artificial intelligence. In what way it is a subset? So whenever we are talking about the machine learning, so machine learning is a set of the algorithms by which we can train the machine. We know we train our children or the students. So training should be given, some experiences should be shared with them, some knowledge should be shared, so that their minds will get trained. So in what way this training can be carried out? So there are some number of scientific methods. There are number of defined ways of training the machines. So that ways are nothing but the algorithms. So by which we can see that yes, if you are giving the data and if you are running some algorithm, then yes, we can see that machine has or machine got trained to some extent. So in what way machine can be trained? So that study of that all algorithms is nothing but a machine learning. So if you see now deep learning. So in machine learning, there are so many algorithms like decision tree, SVM, logistic regression, and many algorithms, gradient boosting algorithm, or there are number of algorithms, neural network. So these are all the machine learning algorithms. So neural network is one of the algorithm of the machine learning only. So whenever we are talking about a neural network in the context of a machine learning, it means we are talking about the neural network having maximum 3-4 layers only. Input layer, output layer, and in between the input and output layer, there can be 1 or 2 hidden layers. And it is written, or it is mentioned in many of the literatures that the neural network with maximum 1 hidden layer can approximate any complex problem in the world. So this maximum 1 or 2 hidden layer we have to consider. We cannot see there are 3, 4, 5, 6 hidden layers. So whenever neural network with 1 or 2 hidden layer is there, then we are talking about the machine learning neural network. That is called as a traditional neural network or artificial neural network. But this neural network, the thing is that we can give a CSV file data having rows and columns. Suppose if I want to give a machine image data, nowadays if you open any social media platform or any application, you will find the data is not only in the form of a textual, but it is in terms of videos and images. So suppose I want to apply the machine learning to the images, then I cannot apply it directly. So what I have to do between before giving the images to the machine learning, I have to extract the features from the images. So feature extraction is additional step that we have to do. And there are number of thousands of feature extraction techniques available in the literature. So that is the challenge of a researcher, that which feature extraction method they are selecting from the literature for which kind of images. Suppose medical images, some ABC method will work properly. If suppose forest images are there, some PQR methods will work. So it is on the expertise of the researcher that which feature extraction methods they are selecting, so that good amount of features should be extracted from the images, and based around that images feature extraction only, the complete accuracy and the efficiency of that model will depend upon. Therefore feature extraction should be extracted very carefully. That's why we call it as a handcrafted features, because by using the feature extraction technique, these features are extracted, and then these features can be given to the machine learning. Directly we cannot pass the images. So features extracted should be passed to the machine learning. So that is the thing. As I said, it is the challenge or expertise of the researcher that which methods they are using. So it should not be dependent on that. So it should be the we also want to hand over this particular task of extracting a feature to the algorithm only. Then this deep learning came into the existence. So whatever the neural network we are considering in the machine learning, if this neural network is having so many layers in between, then we call it as a deep learning. So always in case of a deep learning, these neural networks have so many layers, not 2 or 3 layers like a neural network of a machine learning. So what these many layers do in the deep learning, like 10 layers, 50 layers, 60 layers, any number of layers, depending upon the problem at hand, this deep learning neural network can contain. So deep learning is only focused on the neural network. So it is carrying over the neural network algorithm of the machine learning. The extension of the machine learning in case of neural network is a deep learning. So many layers, what these layers are doing. So these layers are, some of the layers are doing the work of the feature extraction, and some of the layers are working the classification job, like the machine learning. It means deep learning is equals to feature extraction plus machine learning. In this way we can see. So deep neural networks, first part is used for the feature extraction, second part of the deep learning neural network is used for the classification tasks. That's why deep learning is considered as a subset of a machine learning. But subset, it means in deep learning we never talk about a decision tree, SVM, other algorithms are not covered. Only we are talking about neural networks only. Any deep neural network you can talk about, or any you study, you will find the neural networks only. But it is not the case that neural network means deep learning only. So in machine learning also, normal neural network, traditional neural networks can be there having a lesser number of layers where we cannot give the images directly. But in machine deep learning, we can give the deep learn images as it is. And nowadays medical data, if you see, many data sets are available in terms of images, MRI images, CT scan images and all that. Therefore, deep learning plays a very important role in the case of images. Okay. So now we will focus on machine learning today. So again, as I said, machine learning is a branch of artificial intelligence concerned with the design and development of algorithms. So whenever we are defining the machine learning, algorithm word should be there. That allows the computers to evolve behaviors based on the empirical data or experimental data. As intelligence requires knowledge, it is necessary for the computers to acquire knowledge. So how our intelligence has grown up from the childhood, because we are gaining the knowledge. So here we are giving the data to the algorithm. It means what is happening, and we are carrying out a training means what? So this algorithm is extracting the knowledge from the data. After the extraction of a knowledge from the data, that data is not useful for the algorithm. So it is working on the knowledge extracted. Whatever the knowledge it has extracted, it will work and it will take the decisions on that. So that's why for giving the knowledge to the algorithm, we are giving the data. So traditional programming and machine learning, if we see, in case of a traditional programming earlier to the machine learning, we were giving the data and programs and we were expecting some output. Like suppose a matrix multiplication program, we were giving a matrices and we were writing a code for addition of the matrices, and then output is added, the sum of the two matrices is the output. But in case of machine learning, what we are giving the data and we are giving the expected output, that what output we want. Yes, you take this data and this is the output of this data, and it is generating a program. In short, not program exactly, but it is generating a model. So algorithm is getting converted into the model. Whenever we are using a term model, it means the algorithm is trained on some data and then that is getting converted into the model. Suppose SVM. SVM is just code. If I'm writing a code of SVM, it is just a program. It is just an algorithm converted into the code. But whenever I'm giving a data and then I'm training the SVM, and then if it is giving a decision for a test data, then I will say that that is a model, because it has trained on something. Type of learning, as you know, supervised, unsupervised, semi-supervised, reinforcement learning. So in supervised learning, input as well as output, and that is used for a classification. Unsupervised learning, here it is used for a clustering kind of thing. We don't give the data output here, only give the data only. Like for example, I want to classify whether apple or that orange, suppose. So I will give some of the values of the apple and some of the values of the oranges, and as well as I will give this particular row represents apple, this row represents the orange. But in case of unsupervised, only we will give the attribute values of the apple as well as orange, and it will group these particular fruits together based on their similarities. Semi-supervised learning, it means training the data having a few desired outputs. Okay, so when this particular semi-supervised learning, because here now suppose 100 samples or 100 rows are there, and then for some of the rows there will be a label, means output will be there, but for some of the rows that output is missing, then we have to use semi-supervised learning for that. Why that label is missing? So whenever we are collecting a data set, real data set, then sometimes suppose that label is not available, that much information we could not collect, or by mistake it is not collected, or that label for some of the recordings, some of the region is not available. Then whenever, rather than excluding that particular data because of not having a label, because data is a gold in this case, whatever the data we have collected, suppose cancer patient data I'm collecting, if I'm getting one cancer patient, that is a very rare task. No? I should not lose that task. So whatever the attribute I am collecting, I will collect that and I will keep. And suppose that person's label is unknown now, whether that person is cancer positive or cancer negative. Then instead of deleting that particular row, I will keep as it is, and I will keep the label empty. So while collecting the data, for some of the patients, I could not collect a label, and for some of the patient, I could collect the label, like that is cancer positive or negative. So this mixture of data also I should use, and I should give to the algorithm. This exactly what these semi-supervised algorithms do. So wherever the labels are present, now for that data, that algorithm is trained, and wherever label is not present, this data can be given for a testing, and then our algorithm will predict the labels. That also can happen if large amount of data is available. So that is a kind of semi-supervised learning. Reinforcement learning, it is a completely different kind of learning. It learns from the rewards and sequences, we can say. So reinforcement learning is nothing but a learning from the environment. So here there is no predefined rules. Whatever the environment reaction is giving, accordingly this particular model will behave. So autonomous driving is an example of a reinforcement learning. Suppose some autonomous car is there without driverless car is going on a road, and it has to drive. So what it will do, if suppose the speed is more, but it is colliding with some object, so it will reduce the speed. If suppose slope is there, then it will change the gear. So depending upon the environment, whatever the road condition currently I'm going through, so that car will change the input. So depending upon the that impulses getting from the environment, this particular algorithm will that behave in that way. So that is the reinforcement learning. So all these things you might be knowing also, input and output learning algorithm, that is a supervised learning. So this input X as well as Y. X is input, means set of features, and Y is the label. Learning algorithm here, any supervised learning. Which are the supervised learning algorithms? SVM is there, logistic regression is there, decision tree is there, neural network is there. So these are all the supervised. So for them, we need to give the data in the form of X as well as Y. Okay, so this data is given, we have trained, then any new input X will come. So model, whatever the train algorithm is converted into the model, then it will predict the output Y for the input. Unsupervised learning, what is the difference between that and this? Here y is not present. Okay, so only data is given, learning algorithm, it will learn, and then it will group these patterns together. Okay, similar patterns based on the similarity between the that input diagram, the label as well as unlabeled. Some circles are there, some triangles are there, but smaller circles that class or that label to that. Suppose these small circles is very much closer to these big circles, so we will give that label as a circle. These small circles are very much closer to the triangles, then we will give that label triangle as a label to this data. That is a semi-supervised learning, because which contains a mixture of the label as well as unlabeled data. So supervised learning try to put what all these algorithms doing, whichever the classification algorithms are just I have mentioned, all these algorithms are trying to separate these patterns by using some line. Okay, so they are trying to learn the equation of this particular line. So equation of the line is this data can be separated by using a simple line in this case, na? Because it is a linearly separable data. So algorithm, whenever we are giving this data, the algorithm's job is learning the equation of a line which can separate these two particular point, these two set of points. So what is the equation of line y equals to mx plus c? So m is a slope and c is the intercept. So in that way, whatever this equation of this line, it will be learned. Suppose this horizontal line is there, suppose whatever the mouse I am dragging, this line will not separate these two sets of points together. So learning this point line is of no use. So how algorithm, whenever you are starting with training, how this particular algorithm will start? Initially, it will draw the random line. Suppose this line is not separating any points. Then slowly it will converge and it will come up with a line that separates this point. So we will train the algorithm for number of epochs. So after each epoch, this line is getting more and more correct. That separates these points in best possible way. So reinforcement learning, as I said, agent is there. Suppose your car is there and environment is there. They are giving the reactions or rewards to the agent, and accordingly that agent is taking the action. So now if you see this example, training example, suppose there are some of the attributes: author, thread, length, where, and the class label is just skips or reads, like whether that author is going to skip the book or whether author is going to read the book, depending upon the different features. So we have to train such data for algorithm, and then after training on this particular data, the algorithm will learn the mapping between this class and then features. There are 4 features, no? Here, where, length, thread, and author. These are the 4 features, and this is the output class action. So what algorithm will learn? Algorithm will learn the mapping between these 4 features and the output class, so that whenever these 4 feature values are given to the algorithm, it will predict automatically this what is the action, that is the class label it will predict, because it has learned the mapping function. If you are inputting these values, then automatically y will be calculated, and that will be either skips or reads. So in this way, that training testing happens. So training set, training algorithm, testing, and predicted y. In this way, training testing will happen. Again, the same thing. Whenever images are there, then here input images we have to give also the label. Suppose MRI image, COVID positive, COVID negative images, suppose. So label will be given, images will be given. Here feature extraction will be the additional step in this case now, because images are the input. Then extracted features and label will be given to the machine learning algorithm. And machine algorithm will be trained, so it will get converted into the classifier model. And also whatever test images are there, for test images also we have to extract the features, and the extracted features should be given to them, classifier model. Then it will give us the label, whether that COVID positive or cancer positive negative, for whichever the data we are training. So different algorithms have different learning ability. Suppose the same data I am giving, like classification of a cancer, to the SVM I am giving, suppose to the decision tree, although all are the good classifier, but we cannot say that SVM is good, giving the highest accuracy for all the data set. So it completely depends upon the problem. For the COVID, some SVM may give the good accuracy. For cancer, some decision tree may give the good accuracy. So it depends upon the learning ability of each of the classifier, that how well they are separating the 2 categories of points. So what is the learning ability of a classifier? Suppose here there are blue color points and red color points. These are the data points. And now algorithm's job is to classify them, is to learn that is separating boundary among these two set of points. And suppose there are three classifiers I'm using, suppose some yellow color, black color, and some green color. Each classifier has separated the points by using this particular line. So you can tell me that which classifier has done the best job, because any classifier's job is putting a boundary line among the classes. So this is a training data. So they will put the boundaries. So if you see now this green, whether green is a best line or yellow is the best line or black is the best line, which is not the which is the worst line? Please tell me which is the worst line that is separating these two set of points. Can anybody tell me? Worst line.
Black.
Best or worst?
Brown one is worst, ma'am.
Brown is upper line you were saying, no, this?
No, lower one, near to red.
Near to red. This is the worst.
Gray one is the best.
So upper line, no, green line is the worst line. If you see now on one side of, when we call it as a best, on one side completely blue point should be there. On the other side completely red point should be there. It should separate properly. If you see the topmost line, it is not separating, no? Because on that side blue are there, but on this side also blue are there. It means it is not a good line, first line. Now there is a confusion between the black line and this yellow line. So now we will see that if you count, so now you just consider the red, that black line. If you consider the black line, so this black line has made the mistake for the first point. Red, one mistake is there, because on it should be on that side, so completely blue should be there, but red is there here, one mistake. Then if you see for the here blue point, second mistake that black line has done. Then which more mistakes this black line? So two mistakes are done by the black line. I think this is the third mistake. Okay, one more point is there on this by the black line. Three mistakes are done by the black line. Okay, and now if you consider yellow line, then on this side completely blues should be there, but here four reds are there. Here only four mistake I found. And again see here one more. Here again some more. So black is the performance. So how well they are separating accordingly. So if we print the accuracy of the black line will be highest, because how many mistakes I said? Three mistakes. Na? Suppose consider these are the 50 points and it has made for the 3 points mistake. It means how much percent error? 6% error. 6% error means 94% accuracy of the that particular black line. So in the same way accuracy will be calculated. And what happens for the training data, they put these boundaries, they learn these boundaries. Okay, and after learning these boundaries, they don't have to do anything with training data, because they will go ahead with the boundary. Suppose algorithm 1 has learned this black line, this boundary is okay. Now whenever testing data is coming, suppose testing data is somewhere here in the place of class B. Okay, suppose here some point is there. So what they will do on upper side of the black boundary, whatever is coming, they will say it is a blue class. Whatever the downside of the black line is coming, test data is coming, they will see it as a red class, because for the test data class label is not associated with that. No? So only based on that line, they will classify the test points. They don't need the training points, because training points are only used for drawing this particular line only. Once line is perfect, now no use of the training point. Whatever they have to, algorithm has to extract, it has extracted in the form of a line only. Now only test points needs to be classified. So that this is a learnability. Now, just some of the concepts before starting any algorithm: underfitting and overfitting. These are also very important concepts. Underfitting and overfitting. Whenever we are saying machine learning, underfitting and overfitting, we come across. These are the two problems. Actually, these both the things, both are the names of the problems only. Suppose my model is suffering with underfitting, it means there is a problem. If my model is suffering from overfitting, then also it is a problem. So these two problems are of two different kinds. Thus we will try to understand what is the meaning of this. Underfitting means what? Model isn't able to capture the dynamics shown by the same training or set, means limited capacity of the model. So what is the meaning of this? Suppose my data is complex, and suppose I have to use the neural network, artificial neural network, very simple data. So if suppose I am using a very simple model for the data problem is complex, but very simple model I am using, having only one layer, but only 2-3 nodes in each layer. It means that a particular model will not capture the difficulty of the data. Like suppose, again in common sense, like I will give some example. Suppose 10 standard problems are there, and if I'm giving first standard student to solve that problem, if you consider the model or model of the brain of that first standard student is not that much developed. So if that model is simple, but the problems are very complex, 10 standard problems are given, then that particular student's mind, although he is a very clever in the first standard, he is a topper of the first standard, suppose, still that student is not able to solve that because his mind is not that much trained, or is not to capture the difficulty of that problem. No? So that is called as underfitting. So means model is simple and data is complex. Okay. Then underfitting. What to do whenever underfitting is there? How to check whether really my model is like KNN is a very simplest model. It gives very good accuracy, but for some of the problem, it may be underfitting. Like model will become very simple. So how to check? Whenever high training error is there on the as well as high testing for the training as well as for testing data, it is giving very high error. At least for training data, it should give some good accuracy, no? But it is giving very less accuracy or very high error. It means training data also it is not getting learned. Okay, like examination also. Suppose we are taking some problems in a class for students, and for if you are giving some test problems in the examination, so the students which is not available, which is not able to solve the problems in a class, that student will not solve might not solve in the exam also, no? Because training is not even proper in that case, because model is very simple. Okay, then that is called as the underfitting. Then how to solve the underfitting problem? Yes, we get to know, because my training error is very much less. Then yes, definitely there might be a problem of underfitting. What should I do? So we have to increase the capacity of the network. Means like suppose in KNN, increase the value of a K, or suppose in the decision tree, maybe depth, width of a tree. In case of a neural network, you increase the number of nodes and the layers. So in this way, complexity of the model can be increased, so that that model will learn the difficult problem. So this is underfitting problem. Now overfitting problem. Here, overfitting problem means model isn't able to generalize. Means model is very complex and problem is very simple. Okay, like suppose engineering student is there, and I'm teaching them. Suppose 10 times I'm teaching them that how to add the two numbers. Okay, so that's I'm telling that students, you listen carefully what I'm teaching, and that student just remember the problems as it is, because that problems are very much simple for that student. You know? So as it is question, answer, everything he will remember. Remembrance will happen here. Generalization should not happen. And whenever we are talking about a learning, this is a concept. Here we cannot remember. Learning should always the generalization of a thing. Okay. So whenever teachers are taking problems in a class, we never remember mathematical problems. We never remember the steps, and as it is like each value intermediate steps and the answer of each intermediate step, we never remember. We learn from the problem solved in the class, and we whatever we have learned, we apply that learning in the during the examinations, and we solve the unsolved problems also. So that is called as a generalization. So learning is always based around the generalization. It is not based on remembering the things. So overfitting, it means model is very complex, problem is very simple. So model is easily remembering the training data. Model is not generalizing the training data. So what will happen? Model will remember all the training data as it is. And whenever some unknown data is coming, so model is not able to solve the unknown data, because model is too complex and it has learned, it has remembered each and everything. Okay, so model isn't able
Hello, Swati ma'am. I request participants to please wait. I'll just call ma'am. I think there is some connectivity issue.
ते मॅडम पण उचलत नाहीत सर. हा
त्या फोन उचलत नाही म्हटल्यावर ते त्या बोलत असतील समजा
बघूया.
त्यांना वाटत सुरू आहे.
I request all the participants to please wait for 5 minutes. I request all the participants to please wait as there is some connectivity issue on speaker side.
दुसरं पुणे म्हणून तर नाहीये तसं काही. खूप फार झालं तर तुम्ही त्याला काय डिवाइड करू शकता. पण 3 कसं होतंय ते जर इक्वली डिवाइड केलं तर परत ते ऍव्हरेज भेटेल. हो ना, तुमच्याकडे हेडिंगचे मार्क्स आहे. समजा आता 5 मार्काचा ए बी, 5 मार्काचा बी बी. तुमच्याकडे टोटल तुमच्याकडे मार्क जे आहेत ते क्वेश्चन 1चे 10 पैकी किती किंवा क्वेश्चन 2चे 10 पैकी किती असे मार्क्स आहे. त्या केसमध्ये तुमच्याकडे एक पर्याय जे अपेक्षित होतं की मार्क्स असेल सीओ जे नाही आहे त्या चॉईस देणार असं त्याच्यात डिवाइड होईल. त्याच्यात डिवाइड कधी करणार तुम्ही जर तुमचा क्वेश्चन 1 क्वेश्चन 2 इक्वल वेटेज असला तर. तो जर इक्वल वेटेज न असेल
Hello? Hello?
Yes, sir.
Participants, we are calling ma'am. We are trying to connecting the ma'am but ma'am is not picking up phone. So wait for some time. Okay. Once we get the feedback, now accordingly we'll convey a message to you. So wait for few minutes. I'm continuously calling ma'am, but she is not picking up phone because there may be some internet issue or technical problem. So once I get feedback from the ma'am, accordingly I will convey to you. So wait for few minutes.
Yes,
So
participants.
I just see joining the meeting. Participants, ma'am is joining the meeting. Just I talk with her. Hello. There is a problem of internet. So because of which problem occurred, and just I talk with ma'am and she is joining the meeting.
Hello.
Yes, ma'am.
Yes,
Ma'am,
ma'am, you
yes,
are
ma'am.
audible.
You are audible.
You're audible.
Extremely sorry. I think it was a very long time. I feel no. I was
Yes,
disconnected.
ma'am. We were at underfitting and overfitting slide.
Oh my god, my god, my god, my god. Okay, let us start then. No problem. Should I start then from that point?
Yes, ma'am. But your screen, you will have to share the screen.
Yes, yes, I will share it. Actually, many phone calls were coming now, so just some time before only I made my phone silent. Okay, let us start now. No problem.
Okay, ma'am. No issue. No issue.
Yes, sir. Now screen is visible, I think, no?
Yes, ma'am.
Yes, ma'am.
Just we have to do it full screen. Yes, yes, ma'am. It's okay.
Okay, this slide is not covered, na? Feature reduction. Okay. I will start from this point now.
Yes, ma'am.
Okay, now I will keep my phone on non-silent mode. So whenever this problem is there, please tell me. Okay. So feature reduction, as after covering underfitting and overfitting, I was saying like feature reduction is a very important activity in any machine learning algorithm. Not only the choosing the correct model, but whatever the data we are having, that data should be clean data. It should carry some useful information. Then only predictions will be right. Therefore, good amount of data should be there, and not only good amount but good quality. So we can apply some pre-processing technique so that some performance of the algorithm should be or will be improved. Okay. So what thing can be done with the data? So in general, it is the understanding that if you have more features, no, it means more information we are having. Like for example, suppose for a student, if I am collecting features, I want to classify that student whether will get place or will not get place. So if I am asking the student like more features, what is your semester 1, semester 2, semester 4 marks, first year, second year, what are your 10th, 12th marks, and what are your courses. Obviously, as I'm going collecting more information, I will be in a position to classify that student more correctly. But again, suppose more information I'm collecting, so because it is giving more discrimination power to categorize that student in one of the category, maybe excellent average or maybe place or not place, whichever the classes. Therefore, always there should be more information available with us. But in practice, always many reasons there, why this is not true. But in some cases, this is not true because as I'm collecting the attributes from the, about the student, but suppose I started collecting as somebody has told me that more features should be there. Therefore, just I'm asking the student so many values about him, like what is your birthplace, what is your city, what was your 10th school, where you have done your UG, KG, what is your grandfather name. So suppose unnecessarily more information if I'm collecting, then these features will not add any value. So it is not always the true that more number of features will work. So relevant features should be there. Therefore, there is finally or there is one commonly used term is there, that is curse of dimensionality. So what is the meaning of dimensionality? Dimension is nothing but the number of features. 4-dimensional data means I have 4 features in my data set. 10-dimensional means 10 features are there. And curse means in Marathi sharp. It's bad thing. So curse of dimensionality means what is the meaning of it? So here, as we are increasing the number of features, to some extent, it will improve the accuracy. If you see this particular graph now, on x-axis, the number of variables are there, number of features. On y-axis, that classifier performance is there. So as you are increasing the number of features, classifier performance is getting improved. But again, after certain limit, if features are increased, then this classifier performance started degrading. It means it is not always true that more features means more power or more accuracy. So relevant features means here we have to stop to here whatever the topmost point of this particular graph. So that many features should be there in the data set. So relevant means here relevant feature should be there. So to have a relevant features in the data set, what we should do? So the step is feature reduction. Feature reduction is reducing the features. Okay. So what type of features we want to reduce? Irrelevant features, redundant features. Redundant means repeated value. Irrelevant means unnecessary. Like grandfather name of a student is not necessary. Redundant means suppose that students like third year marks and both the semesters mark of third year, not necessary in some cases. So this redundant feature should not be there because they may confuse the learner, and in our case learner is an algorithm, so algorithm will get diverted. Therefore this might be a problem. So these are the problems in the training. This can happen. Limited training data. In some cases training data is limited but more number of features are there, like 10 suppose 50 records are there but 60 features. That is means this particular problem is not good. So limitation of computational resources. Also we have a, because as we are increasing number of features, suppose I am training the algorithm with 50 features, and if I reduce that algorithm features to the 20, and if I am training, suppose I am getting equal accuracy, then why not to have a 20 features? Because 30 features are removed, they have saved my computational power. So this is the thing, and core sum dimensionality, as I said, because of that also feature reduction is necessary. Feature reduction has two sub-techniques. In general, meaning of feature reduction is reducing the features, but either we can go for a feature selection or we can go for a feature extraction. Many times these two terms are used synonymously, both have the same kind meaning, but there is a difference between these two terms. Both are talking about feature reduction only, but what is the difference we will try to understand here. Here, feature selection means what? Whatever the features are having, some features I'm deleting and some features I'm keeping. Suppose 20 features in my Excel file or CSV file. So I will delete 15 number of feature, 10 number of features because they are not at all necessary, I feel. I will apply some criteria and I will predict that yes, feature roll number is not necessary, address of the student is not necessary. So deleting some features and keeping other features intact in the data set is called as a feature selection. Okay, so selecting some subset of features. And what is the feature extraction? In the feature extraction, we are not selecting someone extra.
Hello, ma'am. Hello, Swati, ma'am. You are not audible.
हा मॅडम जॉईन केलं मी आता. Yes, I think we can start now again or start again, no?
Yes, ma'am.
Feature extraction I was talking about, and feature selection. Feature selection is keeping some feature, deleting some of the columns. Feature extraction is nothing but the whatever the features, suppose D features are there in the original data set. These features I will convert into the k number of features where k is less than D. Like principal component analysis is a widely used feature extraction technique. Whatever the features we are giving, we give the complete data set as input to the PCA, and we mention how many principal components we want. Suppose 20 features are there, and if I'm mentioning number of components should be 7. So all these 20 features will be converted into the 7 new features. So that is a feature extraction. Means completely new set of features we will get here. So either of whichever we can go for, and we can do, if we have a good domain knowledge of which feature to be selected and not selected, we can go for feature selection, or else we can go for a feature extraction. Now next, yes, these are all the concepts about machine learning that not only the algorithms, but these all things are very much important: pre-processing and also evaluation and cross-validation. So yes, data is there, algorithm is there, we have trained the algorithm, but how we can evaluate whether algorithm got trained correctly or not? So that suppose if we want to evaluate, because like for our teaching learning process also, we evaluate our teaching learning process. We take a feedback, or we before students appear for a final examination, we conduct unit test also. Because of the unit test, we get whether teaching has happened correctly or not. For some of the units, suppose student has solved very less number of questions, we may revise that particular unit. So in this way, evaluation of the training should happen, then only it should be deployed for the testing. So which are the ways by which we can evaluate? So there are a number of performance measures like error, accuracy, precision, recall. These are the performance measures by using which we can evaluate the performance of the machine learning algorithms. See, there are two types of main evaluation strategies. Either we divide the data into the training and testing set. Like suppose the 100 samples, 100 records are there, and 80% kept for training and 20% for testing. Then I will train on 80% and I will evaluate the algorithm on 20%, that how it is predicting about on this 20%. So whenever we are splitting the data set into training and testing, then always we have to use this performance measure: error, accuracy, precision, recall. But there is another way of doing the performance evaluation without dividing the data into the training and testing. That is a k-fold cross-validation. This is also the most acceptable and most believable way. Many research papers expect that the k-fold cross-validation should be done. So that we will try to understand. So these are the formulas of the errors by which we can measure the performance. Like in all the formulas, if you see all these three formulas, common thing is the two quantities are there. Difference between two quantities, f of x and y. What is this? If x is given as input, then f of x is output, predicted output. Whatever our algorithm has done the prediction about the test sample, that prediction is f of x, and actual output of that particular pattern is a y. So that difference we are taking. If there is no difference, means zero error, because whatever the actual y value was there, an algorithm also has predicted the same value, means difference will come as a 0. Okay. And if higher is the difference, higher is the error. So 1 upon n is the number of training samples. Here absolute error is taken, absolute value we are taking. In the second formula also, the same two quantities are there, f of x and y. Here we are taking a difference, but we are squaring that difference and the summing up that difference on 1 by n. Okay. In both the cases, we are taking the difference of the same quantities, but in the first case, we are taking absolute values. In the second case, we are taking the square, because here positive and negative differences should not cancel. Suppose for some of the record, the -5 is the error, and for some another record, 5 is the error. So 5 plus -5, I'm summing up the errors, then it will be 0 error. Although they both have done the errors -5 and 5, but the resultant error will be 0. Therefore, positive and minus differences should not cancel each other. Therefore, this absolute value and the square value are taken. In some cases, we prefer square, but absolute. Or in some cases, but the purpose of both the things is avoiding the negative difference here. So these first two formulas can be used for regression, because here we are taking a difference. The subtraction of the only numerical quantities can be done, and numerical output, actual as well as predicted numeric output, is for the regression problems. So this is used. In case of a classification algorithm, whenever your classifier is predicting the probability of being in one of the class, then whenever probability is coming as output, that is numeric output, then we can use these two formulas for the classification even. The third formula is mainly for a classification whenever the algorithm is giving the output as a categorical label, like decision tree gives, whether class is yes or no, leaf or nodes of the decision tree, then that is a this formula is used. What this formula is saying about this delta function of f of x comma y. Means if both of these predicted and actual output are matching, it means if they are matching or if they are not matching. If suppose they are not matching, means that is not equal to, then the value of that delta is a 1. If they are matching, means value 0. So if misclassification is there, then 1 will be added here, otherwise 0 will be added. And in this way, for all the samples, this addition will be done divided by the number of samples, then that will be the misclassification. Suppose there are 50 classes, 50 records, and for all the 50 records, misclassification is done, then this value will be evaluated as a 50. 50 upon 50 means error will be 1, maximum error. Okay. Suppose 50% misclassifications are there, 25, then 25 upon 50 means 1 by 2, 0.5 will be the error. Also the confusion matrix, you know, it for the classification it is mainly used two class and hypothesized class. Actual class is this columns represent, and the predicted class is nothing but a row. So if suppose actual class is positive and predicted class is also yes, means positive. So then TP means correct classification, correct positive classification. Actual class is also negative and predicted is also no, it means correct negatives. So TP and TN represents the correct classification of the classifier, correct work done by the classifier. FP and FN represents the mistakes done by the classifier, how many mistakes it has done. So if I want to calculate the accuracy, then TP plus TN upon total records I can do. If I want to calculate the error, then FP plus FN upon the total patterns number of records. So these are the formulas based on the that confusion matrix. It is accuracy, precision, recall, and FP rate. So depending upon the capability of a classifier to deal with a positive sample and negative sample, if separately we want, then precision, recall, and FP rate are used. Otherwise, classifier is a widely used classifier. So next term is a cross fold validation, that is k-fold cross validation set. So as I said, one way of evaluating the algorithm is the training and testing splitting. Another way, alternative way is rather than dividing the data into the training and testing, I can divide the original data. I can some of the data I will keep for testing separately, but for the training data, whatever the thing is there, what I will do here, some folds are there. Suppose this is the one way, that is training and testing. This is the another way, k-fold cross validation. So training test of what we do, testing what we do, we divide the data into the training and testing. In again training, we divide the data into the training and validation. So many times there is a question that what is the difference between validation and testing? So difference is training data is completely used for training the algorithm, and validation data is used whether that training has happened correctly or not to correct the training. Suppose training has not happened correctly based on some performance parameter, maybe error or accuracy. Again, the retraining will be carried out internally. So validation's output is used for modifying the training. After each epoch, this validation accuracy based on that accordingly training will be modified. And this validation gives the feedback. Suppose we take a feedback of our teaching, learning in between after 1 month of teaching. So based on the 1 month feedback, we modify our rest of the 2 months of teaching. Okay, so that 1 month feedback is the feedback after the first month is nothing but the validation accuracy. And feedback taken at the end of the semester, we may say that it is a testing accuracy. Okay, so this is the way done. Another alternative way to the training testing is the k-fold cross validation. Okay. So what is the k-fold here? We are not dividing the data into the training testing, but what we are doing, whatever the data is there, we are dividing that into the n number of folds, like k-folds we can say. Is suppose the value of the k is a 10. Then whatever the data is there, I will divide that into the 10 parts. Suppose 100 records are there. I will divide that 100 records into the 10 folds, means 10 records. 10 records, then second fold 10 records in the third. So I will have a 10 sets, having a 10 records in each set. Okay, so what I will do in the first round, first set will be given for testing, other 9 test sets will be given for a training. Okay, and then I will see the accuracy on that particular set, 93%. In the second run, I will give second set for testing and rest of the 9 sets for training. In the third run, third set will be given for testing. In the same way, for the round number 9, 10th set will be given for testing and remaining set will be given for a training. So for each of the set, I will record the accuracy. And suppose these are the accuracies, whatever I got. And the total accuracy I will calculate by taking the average of all these accuracies, all these 10 accuracies. If 10, the value of a k is a 10, then the 10 rounds will be there. Suppose value of the k is a 3, then data will be divided into only 3 parts, and 1 part is given for each time for testing. So 3 accuracies I will have. I will take the average. Why it is a more good measure of the performance rather than accuracy? Because suppose this is the case, this is the third, like which is the highest accuracy last round number 10. Suppose without doing a cross validation, if you use this way, like whatever this randomly you have selected some feature for testing and training. Suppose randomly you have selected this yellow part for a testing and this rest of the part for a training. So you will get a 90% accuracy. But some other researcher has done like this round 3. Randomly he has selected this part for testing and remaining part for a training. He will get accuracy 91%. So you will consider that your accuracy is better. But actually what has happened in this case, whatever the data, so whatever the this researcher has done, actually he got very simple patterns for the testing, but this researcher got very tough patterns. There are some of the tough patterns in the data set. Okay, some tough patterns in the data set that are used for testing. Therefore, here accuracy will be less. Therefore, rather than this random selection of the testing and training data set, researchers or our journal reviewers feel that every pattern should be given for testing, and accuracy on all the patterns should be, then average should be taken, and that is the correct measure of the accuracy. Therefore, cross validation is the perfect measure of the accuracy. Okay, so I explained this particular theory. Now we will start with the regression algorithm very fastly. Regression is nothing but a classification and regression. In case of a regression, the output, it is a supervised learning, right? But the output is a continuous value. Means suppose like a prediction of age of a person, height, weight, color, and some photograph or some details of a person we have taken. The diseases that patient, energy level or BMI index of that person, and what is the prediction of age. Age is a numeric quantity, no? Either we predict it 50, 40, 30. So numeric quantity we are predicting. And also for the training data, also numeric quantity is given, like person's data and their age values are given as a training data. So this is a problem of a regression. So such points are there. What is the linear regression? Whenever training points are there, so best line that fits these points is nothing but a regression problem. Okay, so there are multiple lines that can fit these points together. So see, if there is no line that can pass through all the points, because these are the non-linear points. These points are not collinear points. Okay, so what we want the best possible line that all the points should be nearer to it. If you calculate the distance of these points from that line, that distance should be the minimum, then that line is the best. That is the regression. So in this case, see, not only always the problem is the linear regression. Sometimes points are non-linear also. If you see these blue points here, if you want that polynomial, then it should learn. Then here that sine wave needs to be learned. Okay. 2-degree polynomial needs to be learned here for learning these particular points. Simple line cannot fit any line. If you try to draw, no, there will be many misclassification or that error points will be there. Okay. So these are the different things here. If you see blue points are there, and if you apply the linear regression to this particular, actual nature of the data is a green color sine wave. Okay, that should be learned from the data, because blue points have this S-shaped shape. But if you are applying a linear regression has the ability of learning a best possible straight line. So it will learn the best possible line is this line for him. But if we this is the line, then how many points are far? See, so many points are far from this particular line. So there will be a higher error. Okay. So m equals to 0 means 0 degree polynomial, we can say. Here m is the slope of the line. Slope is the 0 in this case. But slope, if you are trying to increase, then in this case, or see this is the line. Which is the best line? If this is horizontal line or this is slanted line? Comparatively, slanted line is the best rather than the first line. Because if you calculate the distance of all these points from the line, this distance in this case will be lesser. Then third way of graph is like this. Okay. Fourth is this, which is the best training possible, whichever is matching to the green plot. So a red plot in this case is the best. Is also passing through all the points, but it is a overfitting. Although this red plot is not passing through all the points, still it is the best because it has a good generalization ability as compared to the fourth. It is a 9-degree polynomial. Okay. So regression type, simple regression, multiple regression, simple regression and multiple regression. What is the difference between these two? If suppose input is the only one attribute, then it is a simple regression. If there are multiple input features, then that is a multiple regression. Multiple. And always, if you case any real world problem, it will never happen that the data set contain only one feature. It will contain multiple features only. Therefore, it is always a multiple regression problem. Okay. Now, simple as well as multiple has a two again types: linear regression and non-linear regression. Whenever the points are have a linear nature, in case of a simple one variable is there, then a straight line. In case of a multiple features, that linear nature is nothing but a linear plane is there. Points, the linear plane. You know that book is a linear plane only. The book is the example of a linear plane. It's not a straight line, but it is a linear plane. So that whenever data is having a linear nature, then that linear multiple regression or linear simple regression. Whenever data is having a non-linear, like on the earlier slides, here non-linear data, then that is a non-linear multiple regression or non-linear simple regression. Okay, so this is a linear regression. Yes, sir. So always the linear regression, learning the linear regression means learning the equation of line. Here slope is a beta 1, intercept is a beta 0. This distance is nothing but intercept, and the slope from the horizontal, how much high that line is, that is but slope. So the equation of the line, it will be beta 0 plus beta 1x, or anybody alpha 1 you can use, or y equals to mx plus c, means this beta 1 can be m, and b0 can be, beta 0 can be this intercept. So equation of the line will be learned. Okay? And also this error we are adding because some noise may present in the data set. Okay? So we want that some error should be added in the learning process, so that you should not result in the overfitting. Consider the points. I think some noise is coming.
Please mute themselves.
I feel I have a very short time again, half an hour. So I will try to be very fast now. Okay. So whatever the data, this is the data. Here if you see, there are two attributes. House number is just a serial number kind of attribute. Here actual selling price and house size. Suppose based on the house size, we want that house price should be predicted. Then this is the example of a regression problem. If you plot all these 15 points on x-axis, suppose house size, on y-axis price, then these points will be like this. The size and price. These points will be like this. So now job of the linear regression is the best possible line it should draw. Means it should learn the equation of a line. Actual draw means it is for our purpose that we would like to see the line. But actual algorithm, it will learn the line. That is, it will learn the equation of line means it will learn the slope and intercept values. That coefficient values it will learn. Okay, beta 0 and beta 1. In such a way, it will learn that this particular, because unique values of this intercept and that slope will represent the different lines. Now, if you are changing the values, then it will give different lines. So it will set the value of the beta 0 and beta 1 in such a way that this is the best line it will find out. So the distance of all the points from the line should be the minimum. Okay. So also any algorithm you can use. How it calculates? So there is one least square method. By using also you can calculate the value of beta 0 and beta 1 by using these formulas beta 0 and beta 1. Like on the value of x and y, you have to keep x is the input variable, y is the output value. Okay, the product of all the values together and summing up that products, individual values sum of x and sum of y. Then here sum and the square, that is square. We have to square the x value and then we have to take the sum. In this way, we can calculate the value of beta 1 and beta 0. Suppose beta 1 is 1.5 and 1.6. Okay, I have calculated based on this table, suppose, and now I got 1.5 and 1.6. So here I will the equation will become 1.5 plus 1.6 into x. Okay, so for any x I can keep, it will calculate the y. So the aim of the learning is getting this beta 0 and beta 1, so that for any x, y will be calculated. Suppose my house size is 1000, so if I'm keeping 1000, it will give me the price of the house. Because on what basis it is giving? Because it has learned the beta 0 and beta 1 correctly from the past data. So that is the example of a simple linear regression. Why simple? Because only one input variable is there, only the house size is there. Okay, that's why it is a simple linear regression. When it will be a multiple linear regression, when there are multiple variables like beta x1, beta 1 x1 plus beta 2 x2, because not only the house size but the area is locality is also mattering. Okay, what facilities that are also mattering. So if multiple variable features, if you are using for predicting the house price, then it becomes a multiple linear regression. Okay, multiple linear. It is a multiple regression, but it is a linear. Because why it is a linear? Because the equation is a linear. There is no square, any x square, x cube terms are there. Only the power of x is a 1 or 0. That's why it is a linear regression. Why multiple regression? Because there are multiple input variables. Okay, so the equation becomes like this: beta 0, beta 1, beta 2, beta. So through the training process, it will learn the values of all these beta coefficient, beta 0, beta 1 and all. If you keep these values here, then for any unknown test sample, if you are putting the values of x here, that is future values of that your house, then it will predict the price of your house. This is a linear regression problem. Second algorithm is that we will go like one sample regression algorithm I have chosen, and then sample decision tree. And then after that, I will show you some code. So decision tree, decision tree is a classifier. In general tree data structure you might have studied, or tree means it is graphical representation. It has nodes, root node, then nodes and the leaf nodes. Okay, so the two type of nodes. This is the example of a tree. Okay, this is a root node. Outlook is a root node. Then these are the branch nodes. Which are the leaf nodes? Leaf nodes are the bottommost nodes, like no, yes, yes, no, yes. These are the bottommost node. So decision tree is an algorithm where it has a specific structure. The specific structure is like that. All the leaf nodes are nothing but the class labels. Suppose in my data set, yes and no are the labels. So all leaf nodes will have the labels as a yes or no. Suppose in my data set, the labels are average, good, and excellent. Then here all the orange color rectangles will be either average, excellent, or average, excellent, and good. So this will be the labels. So whatever the labels in the data set, that will be the labels of the leaf nodes. And whatever these blue nodes are the branch nodes. Okay, always the data set has some features. That features will be the placed in the blue nodes. Okay, blue nodes. Outlook is one of the column. Humidity, like suppose age, weight, these are the feature names. No? So this will be the feature names in the decision tree. And whatever the that node that has some three output links. Okay, output ages. That ages, actually these are not labels, sunny, overcast, and rain. These are not nodes. Okay, these are just labels to the ages. These are the three outgoing ages for the outlook node. Outlook node is a tree node. These are the possible values of the attribute. Outlook can have the sunny value, overcast value, or rain value. Wind have the possible values strong or weak in my data set. Humidity has a high or normal. Suppose height has an attribute very heighted, short, or medium. So I can put these three values here. Okay, in this way, but this is the structure of a decision tree. Now suppose whenever whenever we are giving the data to the decision tree algorithm, it will draw or it will construct such a decision tree. As the outcome of a tree, as the outcome of a training, we will get some decision tree, logically drawn decision tree. And whenever test data is there, that this test data will be tested against this decision tree, and we will reach to some class. Now just suppose you assume that you have given the data, which data, some data set is there in the slide. So data set you have given, suppose you assume, and this tree is constructed, and now suppose you are giving a test data, then we will predict its label. Suppose outlook is a sunny. Okay, this is the record. Outlook value is sunny, temperature is hot, humidity is high, wind is weak, and whether we should play or not, yes or no, that we want to predict. So how we can predict? Suppose here label is unknown to us. Now how we can predict? Outlook is sunny. So we will check outlook is root node is there. Sunny means whether I should go sunny, overcast and rain. There are 3 branches. So I should go to the sunny because my test samples outlook value is sunny. So here I will branch. Now temperature is hot. So I will see outgoing link of temperature, sunny is temperature or not. There is no temperature from going from the sunny. So I will stop. I will take some other attributes. Humidity. The value of the humidity is high. So yes, humidity is there. Now humidity high is there. High and normal 2 edges are there, but I should go on the way of high because my humidity is high. So automatically I will be dropped to some class level. No. So wind is not at all needed for me for the doing a classification. Only based on the outlook and humidity, the label predicted is a no. So then I will say yes, but label is a no. So in this way, tree will be traversed and we will reach to some of the class label, either yes or no. And that label will be given as the output of the test sample. So out of the training data, tree is constructed, and out of the test data, tree is traversed to predict the class label. So here again, just we will see that how to construct a decision tree. Suppose there are how many attributes in the data set here? Outlook is there, temperature is there, humidity, wind. There are 4 attributes in the data set. Now here outlook is considered as a root attribute that algorithm has chosen outlook as a root node. But how to choose that output should be the root, or humidity should be root node, or here temperature should be. So see, at each level algorithm calculates some value, that is information gain is one of the measure by using which we can calculate which attribute is the best attribute among these, whether output, temperature, humidity, or wind, which is the best attribute. So we will calculate the information gain out of the outlook, temperature, humidity, as well as wind. The maximum value of the information gain is 1, 0 to 1. So maximum value is 1. So for whichever the attribute maximum information gain is there, that attribute will be placed as a root node. So suppose for the outlook, information gain is a 0.9. But for all other is a 0.7, 0.6. So I will put outlook as a that node. After that, whichever the remaining attributes are there, that I will check, I will calculate the information gain of them even. Then whichever the best information gain, I will choose that attribute as the here humidity. Then wind. In this way, that particular thing will be done. Okay. Now here, while selecting the humidity, I have to select the records having the outlook as a sunny. That records only I will take. And by using that records only, I will calculate the information gain of all the nodes. The humidity is having the highest, therefore I will put the humidity here. So in this way, tree will be constructed. So what is the major player in construction of a decision tree? Information gain is a player, important, because suppose if you are putting the very less attribute here, see temperature. Temperature nowhere in the decision tree is used because temperature is not very much important for this application, whether to play tennis or not. Okay, so temperature, and suppose by mistake if you are making temperature as a root node, then your algorithm will give a very less accuracy. Therefore important nodes should be chosen at each step of construction of a tree. So information gain, how it is calculated, just we will see. So in this case, see, A1 is selected as attribute and A2 is selected as attribute. So which is the best that we want to calculate? A1 is having the values true and false. A2 is also having the values true and false. Total number of records are 29 positive and 35 negative records are there. Here in this case also 29 positive, 35 negative record. This is the data set that we got, and we want to select whether A1 should be placed at the root node or A2 should be placed. If you place A1, then split will be in this way. A1 having a true values are total 26 records. Okay. And A2 having A1 having a false is a total 30 plus these records. Okay, these are the 8 positive and 30 negative records. These many records, 38 records have the A1 value false, and these 26 records have a A1 value as a true. But out of 26, these are positive, these are negative. Okay, this is the split, and here this is a split. We will try to identify which is the best. So here what we have to do, we have to calculate the information gain. Here again theoretical definition. So somewhere I have explained. Information gain is calculated based on the entropy. Entropy is nothing but it measures the purity or uncertainty. Okay. So formula for the entropy is like this. So we will calculate, then you will understand. Here the plot of the entropy is here. Here highest entropy means there is a high impurity. Okay, high impurity. There is high uncertainty, we can say. The entropy is 0 means output is certain. Suppose all the records of the same class, here data set contains only one class. Output is very certain. Whichever test sample is coming, we will give the same label because only one class category classification is there. So entropy is 0. It means there is no impurity. And suppose in the 100 records, 50 are of one class, 50 are two of the second class, means highest impurity because proper mix is there. Okay. So in this way, this is the formula for the gain. We have to calculate the entropy of a data set, complete data set, minus whatever the attribute A is there, all the possible values. Suppose true and false values are there. So for the true value, we have to calculate this ratio into for the entropy of that true value samples, and minus because this sum up we are taking for the then false value proportion and the false value data entropy. In this way we have to calculate. So if you see just how the calculation is done, if you see here this 29 and 35, how many samples total? 29 and 35. So we have to calculate the entropy of the data set first. So entropy of a data set is here, somewhere entropy is calculated. Then we will check here how it is calculated. Okay. So entropy of ES, entropy of ES is nothing but 29 and 35, because 29 are positive, 35 are minus negative class example. And the formula for the entropy is proportion of positive, means the 29 upon total, 29 plus 35 is 64 record. No? And the proportion of that negative samples means 35 upon 64. So this is the entropy of ES. Entropy ES we are calculating here. Entropy of ES means entropy of a data set. Positive proportion, negative proportion. Whatever the value outside of log, the same value is inside of log. Okay. So 0.99 is the entropy of ES. Now we have to calculate the entropy for each value of the attribute. So for true value and for false value. Now calculate the entropy for this particular 29 and 35. Now we will calculate the entropy for true value. Is 21 and 5 and 8 and 30. So what will be the calculation here? See, the entropy of 21.5 is 0.71, entropy of 30 then 0.74. Now after calculating these two entropies, we have to put this into this formula. Okay, the main entropy minus this proportion into this entropies for each value entropy. So if we place these two entropies here, entropy we are putting, here this entropy and the same proportion here. 26 by 64, because it 26, 21 plus 5, 8 plus 30, 38 upon 64. So if we will get the information gain of the that particular attribute. A1 is a 0.27, and the similar thing is done for the A2 is a 0.12. So information gain of the A1 is higher, therefore A1 should be placed at the root node. I hope you might have understood this, how entropies are calculated. So this is the data set for which we were doing the things. Total 14 samples and this thing, yes or no class. So here for this data set, we can calculate humidity for each attribute we are calculating, and by keeping humidity as a root node, the entropy gain is 0.15. For keeping wind as a root node, information gain is 0.04. Outlook, if you are keeping 0.247. So for all the attributes, this is the information gain. So for which attribute it is the highest? For outlook, it is the highest, 0.247. So outlook should be chosen as a root node. Therefore, outlook is a root node. And then these possible values of that outlook. Then again here question mark, which nodes should be selected? Now having the sunny values, we will take, and again we will calculate the information gain of the remaining attribute, humidity, temperature, and wind. And whichever getting here, humidity is getting the 0.9 value. So humidity should be placed here. So humidity is placed here. In the same way here question mark, and here we will place a wind. We will calculate the entropy of the remaining attribute, and we will place the attribute. So in this way, this particular thing that decision tree works. Okay. Now here just I will show you one Google Colab file. See here that Python has done our job very easy, because all the algorithms are implemented in the Python. Just we have to import the libraries and we have to run. And that, yes, of course we can do it, because many times we as a researcher we propose some of the algorithms, we calculate our accuracy, and we want to compare the accuracy, our accuracy with all the algorithms. So all the algorithms we cannot implement the existing algorithms. So just we have to use a Python or any tool. We can give the same our data set to all the algorithms, what accuracies they are giving and what is the accuracy given by our proposed algorithm. We compare and we put our claim, see our accuracy is better, or although it is lesser, but the computational complexity is lesser. In that way, we can put our claims. Therefore, these algorithms are very much necessary for comparing our results. So pandas is a library. Whenever we want to do the data analysis, NumPy and pandas for the data manipulation. Matplot is for plotting the things. Cborn again for graphical library, and matrix is nothing but a different for that confusion matrix, precision, recall, and accuracy we want to have. So already learned Google Colab. Just I will show it because I got very short time to execute all these things. So see here, you can import the data set. In what way you can import? You can download any CSV file. You can put into the Google Drive. You can mount it Google Drive so that this file will be here, and you have to read that CSV file, and this file can be read. So suppose if you are reading this file that into the data frame DF, and df.head means topmost 5 rows it will show. This is some orthopedic data set. So it has shown us the some of the patient values. Patients are abnormal or normal. So this is the data. Then df.info means data information. It will give how many nerve values are there extra. This df.info. The df.describe, it will describe the data set, that what is the count, minimum, maximum values about the data set. This is the plots of the data set. Like we are plotting the data set, normal and abnormal. What is the distribution of the data set by considering the each of the different variables. So such plots are very much useful. This is called as a data analysis. We want to understand the nature of the data so that we can apply the algorithms. So such plots, if you are adding into the papers, then they really add a value to the paper. Then here as we want to distribute the data into the train and test split. So here inbuilt function is there. We can import a train and test split, and we can split the data set by using the train test split. Here x and y we are giving, that is y is the label, x is the data set. Test size we are mentioning as a 0.3. It means 30% data will be used for testing and 70% for the testing. So it will divide the data set and it will allocate that into these variables. X train means data train, and label means the label of the train data. Then test data and the label of the train, which means 4 variables. Now we can pass these variables to any of the algorithm. Before that, just see the performance measures we want. So we can import the classification report and confusion matrix from the sklearn.matrix. sklearn.matrix have all these performance measures inside it, and sklearn.module selection have all the modules inside it. Okay, so confusion matrix here we can print here. So this is the code for printing a confusion matrix. So we can call, this is the function, we can call it, this function. And this is the code for predicting the things. So it will predict on the train data and test data. So prediction value will be given to the confusion matrix. So now algorithms here, Navy based algorithm. Suppose if you want to have for sklearn.navy base, you can import the algorithm. You have to initialize with some variable GNB equals to Navy. This is the keyword as it is you have to use, and then GNB is our model name now. So you can give the data, you can pass this data to this model. Then it will give us the fit and predict. It means it will take the data and it will train the algorithm. Okay. And here confusion matrix, we are passing the prediction value. Whatever the prediction it has given as output, no, it will give the output as a test accuracy, train accuracy, and the prediction. Okay. So it will give the this training accuracy as a 76%, test accuracy is like this, and this is the confusion matrix. In this way, confusion matrix. SVM, suppose if you want in Python, the name of the SVM is SVC. So you have to initialize with SVC, and again the SVC you have to pass the model to that. We are passing the model to that fit and predict function is written to that, or you can pass the that data as a, you can use svc.fit also function you can use. So whichever the way you are using that. So it will train. So training accuracy is 100% and testing is 70%. Okay. Here we can say it is somewhat overfitting because training is higher and testing is some bit lower. Okay. So in this way, this is SVM. In case of a KNN, here sklearn.neighbors, we have to import k nearest neighbor algorithm. Here we have to pass the number of neighbors and we will get the performance here. Again, this KNN, CNF, this model we have passed to the fit and predict. So it will prevent the confusion matrix. So just with 1 or 2 lines, we can come up with, we can train the model as well as we can come up with such good performance measures like 10 accuracy, test accuracy, then complete confusion matrix, graphical representation of the confusion matrix also. Here sometimes we want to have a good value of the k in k nearest neighbor. So we can give all the k values, that number of neighbors, and that equal to approximate maybe in the range of 1 to 25. And for whichever the k value, it is giving the good test accuracy and 10 accuracy. Here all are printed and that k value we can freeze. Okay. In this way also can happen. So see, these are the 10 and test accuracies for the number of neighbors. So for whichever the accuracy is highest, that particular 10 as well as test, that k we have to select. So maybe here suppose, or here wherever the both intersection we have to calculate where the testing as well as training accuracy is highest. So by clearly analyzing this, we can come to the number of neighbors. So this is the accuracy of a decision tree. Just import decision tree classifier and you pass this classifier to this fit and predict function. So it will give the accuracy of that decision tree classifier. So many classifiers are there. Decision tree, random forest. Random forest also many times it gives SVM, or random forest gives the highest accuracy. Why random forest is giving the in many cases good accuracy? Because it is an ensemble classifier. It is constructed by using the multiple decision trees. So multiple classifiers are working together and their voting is taken. That's why it gives the good accuracy. So here the accuracy is, if you see 99 and test accuracy is 83.87%. Okay. So in this way, random forest. Gradient boosting classifier. This is one of the, whenever boosting word is there, it means it is an ensemble classifier, because bagging and boosting, these are the techniques that are used for the ensemble classifier. Multiple classifiers are there. So multiple classifier, how we can make efficient use of them, for that bagging and boosting techniques are there. That is the bagging, and boosting is nothing but giving the whole data to the first classifier and finding the mistakes done by the first classifier, and giving the more weightage to the mistake done by the first classifier, and again giving the same data to the second classifier with the weights assigned to the mistakenly predicted samples. More weightage is given to them, and this updated data set is given to the second classifier. So in this way, all classifiers work together. Each classifier will try to find out will try to correct the mistakes of the earlier classifier. So that is the boosting. So other boosting, gradient boosting, these are the examples of the ensemble classifier which uses the boosting as a technique to improve the performance. This is the other boosting classifier. So here see, this is, so we cannot say always the ensemble will give the good accuracy or nothing, no prediction can be done here. See, in this case, it is 83%, but random forest has given the good accuracy as compared to this. So it depends upon the classifier. So comparatively, all the models can be appended together and combined performance can be here taken. So if you see comparative performance, Navy base, KNN, decision tree, random forest, gradient boosting, other boosting, and SVM. So what is the maximum accuracy that we got here? Mean results, whatever we got here, cross validation if you are performing, then here which has given the highest accuracy, random forest has given 78%, and also training testing also it has given I think 89% accuracy. So these are the different plots. This is the box plot. The meaning of the box plot is nothing but outliers are there or not. See, these are the outliers here. So mean accuracy above the mean and below the mean means how much is the distribution that we want to see. So here GNB has some outliers. Okay, so these are the quartiles, different quartiles, 0 to 25, 25 to 50%, and 50% to 100%. Okay, So what is the mean accuracy, whether it is above the in the last quartile or in the lower quartile? That box plot gives the means we can analyze the performance by using the box plot also. So this is somewhat the demonstration of the machine learning algorithms. I hope session is clear, although it is a very basic. I could not prepare in a shorter time, but maybe in the next time. Actually, my main area is biomedical image processing, not image processing, biomedical images and deep learning. But earlier I worked on machine learning. After that, I started on the deep learning. So thank you very much for giving the opportunity. With this, I end session from my side. If any questions, then I will answer.
Yes, participants, if you are having any question, you can put it in chat box or you can unmute yourself and ask. Yes, participants, if you are having any questions, please ask or put it in chat box. Thank you, ma'am. Thank you so much for your valuable guidance and good insight on predictive analytics with machine learning. You made understanding easy by giving examples. Thank you so much, as it was a very knowledgeable session for all of us. On behalf of AISSMS College of Engineering, I extend my gratitude to Dr. Swati Shinde ma'am for sharing her valuable time in guiding us all. Thank you, ma'am. Thank you so much.
Yes, ma'am. Thank you. Can I leave the session now?
Yes, ma'am. Thank you. Participants, please wait. We are sharing a attendance link here. Yes, dear faculty members, link is shared on WhatsApp group, so you can give your attendance there. Today's session is over, and I request all the participants to please join tomorrow 5 minutes before the scheduled time. Thank you, everyone. Thank you.